Greetings, everyone. I hope you are well, in good health, and surrounded by peace.
Welcome to the channel
Today we begin our exploration
of one of the most mysterious subjects.
in modern science, dark matter.
What is it?
Why do scientists believe it exists?
And how did the idea even begin?
To understand this, we must go back to the 1930s. A Swiss-American astronomer, Fritz Zwicky, was observing galaxies in the Coma cluster. He noticed something unusual. The galaxies were moving so fast that based on visible matter alone, they should have flown apart. But they didn't. Something unseen was holding them together.
Zwicky called this missing mass.
Dunkelmaterie, German for dark matter. It was a bold idea, and at first, many did not take it seriously. Decades later, another astronomer, Vera Rubin, provided powerful evidence. In the 1970s, she studied how stars rotate around galaxies. According to Newtonian physics, stars further out should orbit slower, like planets in our solar system. But Rubin found that stars on the edges of galaxies move just as fast
as stars near the center.
This was a shock. It suggested that a massive invisible presence was spread throughout galaxies, creating extra gravity. The name given to this mystery, dark matter. Before we move to our today, I want to say this clearly. This channel is user-friendly.
No offensive content, no misinformation.
We explain things with respect, curiosity, and authenticity. So dark matter is not just space dust or normal matter hiding from us. It is something entirely different. Scientists now estimate that around 27% of the universe is made of dark matter. Compare that to only 5% being ordinary matter, the stuff that makes stars, planets, and even us. This means everything we see is only a small piece of reality.
The rest, hidden, silent.
Yet shaping the universe remains dark matter. To continue, let us ask the question, what could dark matter actually be? For now, we cannot see it, touch it, or hold it in a laboratory. It does not shine, reflect, or absorb light. This makes it invisible to telescopes. But its presence is detected through gravity. Like a silent architect, it shapes galaxies, clusters, and even the largest structures
in the cosmos.
Scientists have proposed several possible explanations. One idea is that dark matter could be made of particles that are different from the ordinary atoms we know. These hypothetical particles have special names. Some are called WIMPs, which means weakly interacting massive particles. The word weakly describes how rarely they interact with normal matter. If WIMPs exist, they could pass through Earth and even through your body without you ever noticing. Another candidate is Axions. These are extremely light particles,
so tiny and ghost-like
that billions of them could pass through us every second without a single effect. There is also a third possibility, that gravity itself works differently on large cosmic scales. Some scientists suggest that instead of dark matter, we may need to adjust our laws of physics. This idea is known as MOND, modified Newtonian dynamics. However, the evidence we currently have
fits better
with the dark matter model. For example, computer simulations of the universe show that galaxies would not have formed the way we see them without the presence
of dark matter. Imagine the universe
as a giant web. Normal matter, like stars and gas, is spread along this web. But the web itself, its invisible scaffolding, is made of dark matter. Without it, the cosmic web would collapse. The most fascinating part is that dark matter may even hold clues about the earliest moments
after the Big Bang.
Because it interacts so little, it preserves a memory
of the universe's birth,
untouched by radiation or heat. This means studying dark matter is not only about galaxies, but also about understanding the very origin
of everything we know.
So far, all experiments on Earth, from deep underground labs to detectors placed in space, are searching for these hidden particles. We have not yet captured them, but each attempt brings us closer to the answer. Dark matter remains unseen, but its fingerprint is everywhere. Now let us explore how scientists today are trying to uncover the true nature of dark matter, because it does not emit light.
Researchers need creative methods
to detect its presence. One approach is gravitational lensing. When light from a distant galaxy travels through space,
it can bend
around invisible masses. Astronomers use this bending effect, like a cosmic magnifying glass, to map where dark matter hides. This method has revealed vast halos of dark matter surrounding galaxies and clusters. Another approach is building underground detectors. Why underground? Because we must shield the devices from cosmic rays and background radiation that could confuse results. In deep laboratories, scientists place tanks filled with noble gases such as xenon or argon. If a dark matter particle were to collide with one of these atoms, it would create a tiny flash of light. Sensitive instruments are designed to capture these rare events. Although no confirmed signal
has yet been found,
the search continues with increasing precision. At the same time, powerful particle accelerators, like the Large Hadron Collider in Geneva, are smashing protons together
at incredible speeds.
The hope is that in these collisions, dark matter particles could briefly appear before vanishing. Detecting missing energy in these experiments could be a clue. In space, satellites like the Fermi Gamma Ray Telescope look for unusual radiation that may come from dark matter interactions. So far, the data is suggestive, but not final. What is fascinating is that dark matter does not only concern astronomers, it also touches physics, cosmology, and even philosophy. Because if most of the universe is made of something invisible, then our daily experience of reality is only a fraction
of the truth.
The pursuit of dark matter is also an example of how science grows. We begin with a mystery, collect evidence, test ideas, discard what fails, and continue exploring. It is a journey that requires patience, humility, and collaboration between thousands of scientists across the globe.
Even though
we do not yet have the final answer, the process itself is expanding our knowledge, developing new technologies, and inspiring the next generation
of explorers.
Dark matter remains a puzzle, but it is a puzzle that pushes human curiosity to its very limits. As we come to the final part of our exploration,
let us reflect
on the wider meaning
of dark matter.
If nearly a third of the universe is made of this unseen substance, what does that say
about our place in the cosmos?
First, dark matter shapes the way galaxies form and evolve. Without it, stars would drift apart, and galaxies like the Milky Way might never have taken shape. This means that dark matter is partly responsible for the very conditions that allowed Earth to exist
and life to emerge.
Second, dark matter connects to another great mystery, dark energy. If dark matter pulls things together, dark energy pushes them apart, driving the accelerated expansion
of the universe.
Together, they dominate the cosmos. Ordinary matter, the matter we know and touch, is only a small fraction. This perspective is both humbling and inspiring. We are part of a universe that is far larger,
stranger, and richer than we can imagine.
The search for dark matter reminds us that science is not about
having all the answers now.
It is about asking the right questions
and daring to look
beyond the visible horizon. even if it takes decades or even centuries.
Each discovery adds a piece to the puzzle.
And in that journey, humanity grows stronger.
In knowledge and unity,
All the information we provide comes from verified historical sources, including books, records,
and archaeology.
For this episode, references include Fritz Zwicky's 1933 study on the Coma Cluster, Vera Rubin's galaxy rotation research, from the 1970 publications of the European Space Agency on gravitational lensing, data from the Fermi Gamma Ray Space Telescope, and reports from CERN
On dark matter experiments. And with that,
I invite you to support us. Like this video, share it with friends, and subscribe to our channel, Thrones of Knowledge. Do not forget to press the bell icon to get notified on time, and please suggest our next topic in the comment section to make this journey a shared experience.